I'll figure out how to handle these 3 pages. Okay.
All right.
You can put Jackson on.
Okay.
Let's go to work. Jackson?
Jack.
Hello?
Okay. Sit down and listen. I'll take the dog out. You have to listen really good. Oh, there you go. Can you hear now?
Hello?
Yeah, Jackson, are you there?
Come on, Stella.
Yeah.
Okay. So, is it a little hard for you to see on these? Unfortunately, if I try to zoom, let me see there. No, let me go back. It flips it, but I can zoom one level, I think. There we go. Should be able to read that. Okay, so it's saying justify each step of the solution. So your distributive property is good. Combining like terms is good. The third step, that's the subtraction property, because what you're doing is subtracting 6 from both sides, correct?
Yeah, I thought in class we did one where it was a plus, so I got.
Well, you know what? The difference between addition and subtraction is very minimal. So I don't blame you for making that mistake. But in order to solve this equation, here, hold on, let me draw it. In other words, we're at this step right here, okay? So in order, the next step in solving that is to subtract 6 from the left side and 6 from the right side. That is the subtraction property of equality. If this was a minus, let's say that this was a minus 6 right there.
Yeah.
Then you would have to add 6 to both sides, right?
And then that would be the addition property.
That'd be the addition property. So it's whatever you're doing to both sides. It's not what it shows. In other words, it is showing that that 6 is being added, but in order to get rid of the 6, you have to do the opposite. So you have to subtract. So you're using the subtraction property.
Okay.
Now we're on this step. What are we doing next?
Simplifying.
Okay, and then what are we doing? Looks like you got the rest of it correct. So am I correct in assuming that if you know the rest of it, we don't need to cover it?
Yeah.
Okay, let's look at number 8. Describe the differences between an equation with infinitely many solutions to an equation with no solutions. Justify your reasoning. You got 2 out of 4 on that?
Yeah.
You can do some drawing here, and maybe I can explain this a little better for you. If I have 2 variables, how many solutions does that have?
1. No, well, 2.
Well, what would it be? What would they be? Give me a solution. Give me an X and a Y that works. Give me an X and a Y that add to 10.
Oh, well, 5 and like 5.
Okay, that works. Give me another one.
7 to 3.
Give me another one.
6 to 4.
Give me one using negative numbers.
Negative 10 plus 20.
How many solutions are there to this equation?
Infinite.
Yes. In other words, you have either one, you have infinite, or you have none. Those are your three choices. And you need to be able to distinguish when you can get one solution. Well, in general, when you have an equation and you only have one equation and you have two variables, you can't solve it. You have to have the same number of equations as you have variables. What if I give you this? Solve that.
That's 1.
How would you solve that?
Well, you just subtract 5 from 11.
You get 1?
Well, no, you subtract, well, x equals 6.
That's the solution. It's not 1. It's 6. Okay? And notice what you're looking at. You're looking at an equation that has one variable only. One variable, you can solve it. It gives you an exact singular answer. The only answer that works is x equals 6. Okay?
Yeah.
Now, let's talk about two equations, because that's clearly what they're doing in your class. So, this question you presented me has to do with two equations. So I know that has an infinite number of solutions.
Yeah.
Now what if I do this? And I treat that as a system of equations. You're covering that, correct? You're taking Algebra 2, is that correct, Jackson?
Yeah.
Okay. Usually, if you have the same number of variables as you have equations, you can solve it and get a unique solution. Let me give you a different example before I give you this one here. Let's say that x minus 2y equals 30. Totally different equation, right?
Yeah.
It's not a multiple of the first equation. In other words, I didn't just multiply the first equation by 2 or 3 to get this. This is a different equation. Can you solve this? Can you solve this system of equations?
Well, I know x minus 2y. You just find your.
I'm not sure what you've been taught yet, Jackson. So I don't know. Have you had systems of equations yet where you use either substitution or elimination to solve them?
I think we have done a bit of systems.
You must have had that. Otherwise, you would not be getting that question you gave me. Okay? So let's talk about the ways you would solve this. Now, I'm looking at two equations that are in standard format. By standard format, I mean the x and the y are on the left and the number is on the right. So, you with me?
Yeah.
The rules of mathematics allow you to add or subtract any two equations. Now, I'm going to try to solve this using elimination. Do I want to add these two or subtract them? What will eliminate a variable? Which operation?
Addition?
Now I'll end up with 2x minus 1y equals 40. That does not eliminate a variable. Remember, my goal is to eliminate. It doesn't matter if I eliminate x or y. I got to eliminate a variable. What else would do it if not addition? You're only allowed to do one other thing.
Subtraction?
Okay. Let's subtract equation 1 or equation 2 from equation 1. Go ahead and do it piece by piece. What is x minus x?
Well, x minus x is 0.
Okay, we eliminated x. Now what is y minus a negative 2y? In other words, you have to take that and subtract negative 2y from it. What is that?
Negative 1y?
Nope.
Wait, no,
It's y minus a minus 2y.
Oh, yeah, that's 3y.
Okay.
Negative 3y.
Plus 3y. I'm going to put the plus sign in it just to be clear. Now subtract the two numbers. In other words, if I'm going to subtract the entire left side, I got to subtract the entire right side.
Which, wouldn't y equal 10?
Well, hold on. What's 10 minus 30? We got to get a right side to this equation.
That's 20.
It's minus 20.
Yeah.
Well, that's important, that minus. You are not getting the problem right if you drop negative signs. Dropping negative signs is the biggest problem I find amongst algebra students. They hate negative signs, so they want to drop them as quickly as possible. You cannot. They're as important as getting the right number. Negative signs are critical. So, what's the answer?
Y. Negative y plus.
How am I solving this equation right here?
Oh, 0 plus 3y.
Well, forget the 0. We don't need the 0. I wrote it there only for clarification. We got 3y equals minus 20.
Well, you subtract 3 from each side.
You don't subtract.
You divide.
Okay, big difference. You always do the opposite of what that thing is doing. Right now, that 3 is a multiplier of y. So we're going to do the opposite. The opposite of multiplication is division. So I'm going to divide both sides by 3. And what that gives me on the right side is y equals minus 20/3. That's my answer. Okay? Now, if I go back into one of these equations, I can solve for x because I know what y is. So y is minus 20/3. That has to all be equal to 10. So x must be 10 plus 20/3. Well, 20/3 is 6 2/3. So x is 16 2/3. And those are your two answers. Now, let's go back and look at what we did. We started off with two equations that were not multiples of one another. They were independent from one another. Okay? And even if you don't understand what that means exactly 100%, just accept it. If you have two independent equations and two variables, you're going to be able to solve for each variable. That's as good as having one equation and one variable. Almost. Okay? In this particular problem, we were able to solve for it. However, let's take this problem. Again, two equations, two variables. One would think that I'm able to solve for this, but go ahead and try to solve for it. First of all, what are you going to do to eliminate a variable?
Well, you're gonna
Subtract or add?
subtract y from y.
No, I'm subtracting the entire left side from the entire left side of 1, and I'm subtracting the entire left side or the right side from the entire right side. So what do you get when you subtract the left side? What is x minus x? What is that?
0.
What's y minus y?
0.
What's 10 minus 9?
0.
Is it?
Well, it's -1, I think.
Positive 1.
Well,
10
yeah.
minus 9 is positive 1. So now I get a solution that looks like that. 0 equals 1. Is that possible?
No.
No, it isn't. You can't have one number equaling another number. That is not possible. When it is not possible, it is no solution. That's how you get no solution. Remember, there's 3 options. You can get an exact solution, which we did on the problem before. You can get no solution when you basically have 2 contradictory equations. You cannot have x plus y equal 10 and also x plus y equal 9. That does not work. It does not give you any solution at all. And you prove it by trying to solve it, and you get a number equals a different number. Whenever you get a number equals a different number, that is no solution. Okay?
Yeah.
One more case. This is very complicated, and the only way I know how to do it is to do this, basically, is to go through all 3 situations. Now, again, we have 2 equations and 2 unknowns. So one would think that maybe we can solve it. You have to have at least as many equations as you have unknowns.
Well, I know that x, a variable, is always going to be 1.
Well, first of all, the second equation is not any different than the first equation. It's the same thing. It's not independent. The second equation is a multiple of 2. Because all I did was multiply the first equation by 2.
Yeah.
That means I don't really have 2 equations. I have 1 equation. And we already know that when you have 1 equation and 2 variables, you get an infinite number of solutions.
Yeah.
Okay. Well, let's try to solve this. I'm allowed to multiply the top equation by 2. And now I'm allowed to subtract. So I get 0 equals 0. Whenever you get one number equals the same number, that is an infinite number of solutions.
Oh.
So you have 3 possibilities. Let me review them because it's important. Although this is, I might add, a difficult part of algebra. I tutor the SAT, and this is one of the tougher questions. Okay? And I usually skip it because I'm time constrained and I don't have 30 minutes to explain it to somebody. But with you, it's a little different because we're doing one-on-one tutoring. So, if I have one equation only and 2 variables, I always have an infinite number of solutions. If I have 2 equations and they are different, I have 1 exact solution for both x and y.
Okay.
And if I have no solution. It happens when the two equations contradict one another. Like this. X plus y cannot be equal to 10 and also equal to 9. Try to think of any two numbers that add to 10. Well, they don't add to 9. Okay? So right off the bat, you can kind of tell that that's not going to have a solution. If you don't know for sure, try to solve it. Subtract. You get 0 equals 1. Whenever you get one number equals a different number, no solution. That's impossible. When you get a number that equals another number, that's infinite number of solutions. And when you get a specific solution for either x or y, you're going to be able to solve for the other variable and you're going to have one exact solution. So go ahead.
Pretty much every time there's so there's two equations and they're not the same, it's going to equal one exact equation, but every time there's...
Not quite. Let me show you a difference. The key thing is you cannot have one equation be a multiple of the other one. That's one equation. If I give you this equation, that's actually an exact multiple of the first one. It's a multiple of -1. I multiplied the first equation by -1 on all sides. So this second equation is not a new equation. That's the key. You have to recognize when it's not the same equation. If I made that 6, made that 8, it's still the same equation. Because all it is the first equation multiplied by -2 on all sides. Okay? If I make this 8 a 7, now it's not the same equation. There's no way I can take the first equation, multiply it by a certain number, and get the second equation. That's the key. If you have different equations, and the same thing, here. If I have this, that's a different equation, right?
Yeah, because
there's nothing I can multiply equation 1 by to get equation 2. So I have two different equations. Now I can solve this.
And isn't that equal to one solution because they're not the same?
Exactly. It's not just because they're not the same. When I had 3x plus 4y, or when I had 6x plus 8y, they weren't the same either. But you still had an infinite number of solutions. In other words, it's not a question about them being the same. It's a question of, is one a multiple of the other? In this case here, equation 2 is not a multiple of equation 1. And if I'm going to solve it, I'm just going to subtract. So the x's go away. 4y minus 3y is y. 4 minus 4 is 0. There's your solution. Y equals 0. Therefore, x equals 4/3.
Wait, why is it equal 0?
Well, I subtracted the two equations. So I get 0x.
Yeah.
4y minus 3y is 1y.
1y and then
4 minus 4 is 0. So I get this answer. Now, once you get an answer for one of the variables, it's just a simple step to get the answer for the other one. So when you solve for one variable, you are getting a specific answer, a unique X and Y answer. Remember, there's only three choices. There's this one, specific answer, there's no solution, and there's infinite solutions. So the moment you solve for one variable, you know you have a specific solution. Even though you haven't yet solved for X, you know that you have a solution. Okay?
Yeah.
Okay, that's a big subject. That's not that easy to deal with. Let me go back and look at your problems and see why in the world are they asking this? Oh, I hate this question. Describe the differences between an equation with infinitely many solutions to an equation with no solutions. Wow, this was written by an English teacher, not a math teacher. What grade are you in, Jackson?
8.
That's why. No math teacher in high school is ever asking you question number 8. What they're going to do is they're going to give you the system of equations, and they're going to say which one has a specific solution, which one has no solutions, which one has an infinite number of solutions. They're not going to make you explain stuff like this with words. That is not math. That's why I know this was written by an English teacher. Math teachers would never write a math problem that required a verbal explanation. Okay? All right. Let's go to your next page here. It's funny how as soon as I expand it to a certain point, it flips it. All right, I guess we're going to have to deal with it here. All right. No calculators. This is some geometry. I assume that whenever I see a fraction, they took off points.
I think so.
Okay. Well, the first problem, what's the sum of the angles of a triangle?
I said 4x.
There's a magic number in geometry you want to learn. That magic number is 180.
Oh, yeah, it's 180.
Everything is 180. The sum of the angles of a triangle is 180. If you have a linear pair like this, A plus B is 180.
Yeah.
Everything is 180. So the magic number in geometry is 180. Okay? So, I've got three angles here. I know they add to 180. Give me the equation.
4x plus 60 plus 20 equals 180.
Yeah, I think it's 3x. This angle is 3x on the lower right. Plus x plus 20. That's the angle on the lower left. Plus 60. That's the third angle. That's equal to 180. Now solve that equation. It's all geometry is about, is setting up equations and solving them.
It'd be 4x plus 80 equals 180.
Keep going.
And then you subtract 80 from 180.
Okay. Just read the next line. I know you know how to do it, so just read the next line.
And then you just
You
divide.
You told me how to do it. Now go ahead and do it and read the next line.
Wait, where's the next line?
We're starting
and
from there. You're gonna
Oh,
you're gonna subtract 80 from both sides.
and then you divide.
Hold on. What's the
No,
next line? 4x equal what?
4x equals 100.
Okay. Now the next line. X equal what?
X equals, and then we divide 4, 25.
Okay. You don't even need to tell me how you're doing it. Just tell me the next line. If you give me a correct next line, I know you're doing it right. Okay? So, that's what the problem was, to find the value of x. We did. It's 25. Excuse me. 1 second. Sorry about that. Allergy season.
Yeah.
All right. Let's see here. Let me erase all of this. And let's go to problem 2. Having a little bit of a hard time reading it. Let me see if I can rewrite it properly. And you tell me. You're probably looking at the original page, right?
Yeah.
Is this correct?
It's 0.6.
I never write that leading 0 because it's not necessary.
So yeah, it's 0.6. And then in the parentheses, j minus 2 equals 3.3j. Yeah, you got it right.
I don't write that 0 either. You see the advantage of not writing those zeros?
It makes the equation easier.
Well, they're not necessary. You don't want to write stuff that's not necessary. It's like if I would have written it like this. Those 3 zeros are not necessary. So you don't want to write stuff that's not necessary. I don't know why high school teaches everybody, not just high school, but middle school also, they teach everybody to write those leading zeros. I never have figured out why. They're totally useless. Okay? Now, we got to solve that equation. It's the first step we're going to do.
We have to solve for parentheses so we distribute.
Yeah, we can see that we're looking at one equation and only one variable, j, right?
Yeah.
That means we're going to be able to solve it. It's going to have a unique solution for j. This is not a system of equations. Okay, this is one equation only. Okay, so distribute. What's the next line?
Then we write the distributed. So 0.6 is gone, and we have the 2 answers. Then we subtract.
Okay. You don't need to describe to me what you're doing, Jackson. Just give me the next line. I know you know how to do it.
-2.
Hold on. Go from left to right. You're distributing that to that first.
0.6j.
Okay, now distribute that to that. Go left to right. Always.
Point.
First of all, is it going to be plus or minus?
Minus.
Okay. What's 0.6 times 2?
0.12.
It's actually 1.2.
Oh yeah.
Notice that, and one way you can do these to make sure you're not off by a factor of 10, because it's really easy to be off by a factor of 10 in these problems. And I noticed you just were off by a factor of 10. You said 0.12. Think about 0.6 as being almost a half, right?
Uh-huh.
Well, what's a half of 2?
1/2. I mean, no, 1.
Okay. So our answer has to be close to 1. 1, 2 is not close to 1. It's not anywhere close to 1.
Yeah.
So this is what I call a ballpark test. In other words, since it's so easy to be off by a factor of 10 in a lot of math problems, then you want to employ this ballpark test. You don't want to make simple mistakes like 0.12. It's not 0.12, it's 1.2. And
Yeah.
I know it because I know that half of 2 is close to 1. That's how I know it. I'm not doing it the way they necessarily teach you. In other words, if you do this, you put 1, 2, and then there's one decimal spot, so you put it there. That's how you multiply 2 times 0.6. And if I'm multiplying negative 2 times 0.6, it doesn't matter. It's negative 1.2. Okay?
Yeah.
So this is the official way they teach you to do it, but you want to get in the habit of ballparking it, always. By ballparking it is exactly what I did. I knew that 0.6 was close to 0.5, which is a half, and half of 2 is 1. So it's got to be a little bit more than 1. Well, 1.2 is a little bit more than 1. Okay, so now we're at this point in the equation. What's the next step?
Subtract 0.6j from 0.3j.
Okay, we could do that. That actually is not a bad idea.
You have to get the variable by itself, so you can.
Exactly. You want to gather like terms, right?
Yeah.
So we definitely want to gather the j's all on one side and the numbers all on the other side.
Yeah.
Well, let's think about something here. Are we going to be better off with negative coefficients or positive coefficients?
Positive.
Yeah. So which side do I want to put the j's on?
3.
I want to put them on the left side.
Oh yeah, because 6 is the higher number.
Yeah, exactly. So if I subtract 0.3j from both sides, I end up with 0.3j on the left. And now I got to move that to the right side because I decided to put the j's on the left. So that actually becomes positive also. And now I've got 2 positive coefficients. Much better than negative. If I would have done it your way, I'm going to get the same answer, but I'm going to have lots of negative signs.
Yeah.
What I'm going to have is I'm going to have a negative 1.2 equals a negative 0.3j. All those negative signs screw people up something terrible. Okay? So when you are solving an equation and you're trying to figure out which side to put the variable on, put it on the side that gives it a positive coefficient. This is a positive 0.3. It's not a negative 0.3. Now what's the last step? J equal what?
To divide 1.2 by j.
Not by j, by the coefficient of j.
Yeah.
Remember, what we're trying to get rid of is that, so that we can have just j. Well, 0.3 is a multiplier, which means I got to divide. What is 1.2 divided by 0.3?
0.04.
No?
No, 0.4.
Nope.
0.4.
Nope. Incidentally, 0.4 is the same number as 0.4. So I'm never going to tell you no just because you add the 0 there. It's just I don't waste my time putting those zeros in. I find it unnecessary. There's already a lot of numbers on the page. We don't need numbers that are irrelevant.
Yeah. Oh.
You have a calculator handy? What's 12 divided by 3?
4.
That's the answer. Now, if you want to check whether that's the answer, multiply 4 times 0.3. What do you get?
Let me go. I'll just do it on paper. I need to find a scratch piece of paper.
Jackson, when we have sessions, you need a pencil, a paper, and a calculator.
Sorry.
In front of you.
I have what is.
So what is, well, first of all, 12 divided by 3 is 4. But 1.2 divided by 0.3 is also 4. No matter how you do it. You do it long division, you do it with a calculator, you do it in your head. The key is, after you're done coming up with the answer, now multiply 4 times that, and you better get 1.2. That means you've done it correctly. Right? They teach you how to multiply 4 times 0.3 by multiplying the numbers, and then there's one decimal place. 1.2. So 4 is definitely the correct answer.
Yeah.
All right. We got a little bit more time here. Let's tackle the next problem, which is number 3. All right. How are we going to do 3? Here, let me write 3 up here. First of all, let me write it in big letters so we can both see it. They're saying that that is equal to 3 times that. Well, let's see if we can solve for x. We've got one equation, and we've only got one variable. So we're going to either get a specific solution for x, or we may get no solutions, or we may get an infinite number of solutions. Let's solve it and see what we get, and from the answer we get, we'll know whether it's a unique solution, no solution, or an infinite number of solutions. What's our first step?
Well, do the parentheses.
Distribute.
Yeah.
So distribute. What do you get on the left side?
Negative 6x. Negative 6x, yeah, and then 6 plus 6.
Good. I need that plus sign. That's part of an expression. I cannot omit that plus sign. I gotta have it. What do you get on the right?
Negative 6x plus 2, and then since that's the same.
Hold on. It's not plus 2.
Oh, it's plus 6.
Okay. So now, if I want, I could add 6x to both sides and subtract 6 from both sides, and I get 0 equals 0. So what does it tell me when I get one number equals another number and the variable is no longer there?
It tells you that it's an infinite solution.
Exactly. Infinite solutions. If I'd have gotten 0 equals 1, what would that have told me?
That it's no solution.
And if I'd have gotten x equals 2,
that would have made it so it was one solution.
Exactly. And those are the only 3 possibilities you get. And it doesn't necessarily have to be a system of equations like I was explaining earlier. You may not have even gotten to a system of equations yet.
Yeah.
But you can have a single equation. and you can still have either a specific solution, no solutions, or an infinite number of solutions. Now, the reason I suspect you got that X right there is because I suspect your math wasn't correct on those steps. In other words, just do your math, start with that, put that as the second line, put that as the third line, your teacher would give you 100%. Well, you still have to say an infinite number of solutions. In other words, you have to know that when you get, and it doesn't have to be 0 equals 0. It could be 1 equals 1. It could be 4 equals 4. As long as you have one number equal to the same number, that basically tells you that no matter what X is, this is a true equation. So X can be anything. So you have an infinite number of solutions.
Yeah.
All right.
Could we do 5?
Yeah, let's do, I can certainly jump to 5. Is that this one that I'm pointing at there? Let's see, we got 3, 4. Is this 5 here? No, let's see. That's
No, it's on a
3A, 3B, and 3C.
It's on a different
6
page.
or 5?
It's on a different page. It's one of the harder ones that we had to do that we only got like a day to learn.
Okay. Let's see if we can do it in our 10 minutes final here.
It's this one right here.
Okay. I'm reading it. Okay. One layout uses 4 identical rectangular mats and 1 square mat. Well, let's see how they do that. There's the square mat, right? Whoops, hold on. Let me write this. The square mat's probably going to be right there. Let me see if this works. And then we need 4 rectangular mats. Well, there is 1 rectangle. There's 2 rectangles. There's 3 rectangles. And there's a 4th rectangle. So that would be one way. Now they say 4 identical rectangles. My rectangles are not identical. So that can't be the way it's done. Let's see if we can do it a different way.
Well, I think it goes like this.
What?
Can you see my mouse?
No, I can't see your screen. You can only see my screen.
Oh.
Okay? So, I'm trying to find 4 rectangles that are identical. How about this? There's 2 rectangles that are identical, right? So
yeah.
that's a 2 rectangle pass. Okay, now how about that rectangle right there? That's the same size. And then we have this rectangle here, that's the same size. And then we have this rectangle here, that's the same size. And what's left over is a square in the middle.
Yeah.
Okay, so we got our picture right. And that's the hardest part of these problems, is to get your picture right. Now, that thing is a square. The whole thing. That thing is a square.
Yeah.
What's the side of each square? If the total area is 81 square feet, How long is each side? What's the square root of 81?
9.
Okay. So that side's 9, that side's 9, that side's 9, and that side's 9. What do you figure the area of each triangle is? Or each rectangle?
18.
Yeah, in other words, that's got to be 6, that's got to be 3. So all 4 of these rectangles are equal, and they're all 18. So we got 4 rectangles times each of their areas is 18. Plus we got that square in the middle. There's one square, and it's got an area of 9. Well, guess what? That adds to 81. So we've done it correctly. We know exactly how it's laid out, and we know the dimensions of every rectangle. Every rectangle is a 3 by 6, and that middle square is a 3 by 3. So let's see if we can answer it the way this English teacher has written it. The area of the square mat is half the area of one of the rectangular mats. Well, that's pretty easy. The area of the square mat is the side of the square mat squared, and that area equals half of one of the rectangular mats.
So the solution would just be 18.
Well, let's start with where we're supposed to start. When you see a word problem in algebra, always start at the end. The very last sentence is what they're asking, or they're telling you to do. Define your variables. Okay? So, I know these numbers, but let's say I don't know them, and I'm trying to figure out what they are. Okay? So, let's take this rectangle down here. I'm going to call X the width and Y the length. So I got X equals the width of the rectangle, and Y equals the length of the rectangle. Okay? So what's the area of each rectangle?
Well, each rectangle is 18.
It's XY. It's the width times the length.
And the width is 3. No, the length.
Don't put any numbers on it yet. Notice what the problem is. The problem is write and solve an equation. So we got to find an equation. We can't just find the numbers right up the way we did it. That's not what it wants. It wants an equation. Okay, so the area of each rectangle is X times Y. Well, what's the area of the square? It's X times X.
Yeah.
Right? In other words, that measurement right there is X. That measurement is X. This measurement is 2X. So we don't even need to use Y. We can say, no, we don't know yet that Y is exactly twice X. So we can't really say that yet. However, what we can say is that there are 4 rectangles. So the area of the 4 rectangles is 4 times XY, which is the area of one rectangle, plus the area of the square is X times X, which is X squared, and we know all of that is equal to 81. So there is our equation. It is in 2 variables. Now they're saying the area of the square mat is half the area of one of the rectangles, which means we don't need to use y as the length. We can use 2x. And that's helpful because then we only have one variable. So the area of the rectangle is x times 2x, where the area of the rectangle is 2x squared. Okay, so now here's the equation they're looking for. The area of each rectangle is 2x squared. The area of that square is x squared, and all of that's equal to 81. So what do I end up with? 8x squared plus x squared equals 81. That's 9x squared equals 81. That's x squared equals 9. That's x equal 3. So now we've solved the problem. And we've done it by doing it with equations. We've written the proper equation, and then we've solved that. That's one equation, one variable. We can solve it, and we get x equal 3. Once we get x equal 3, now we know the dimensions of all four rectangles. They're 3 by 6, and we know the dimension of that square right in the middle, which is 3 by 3. Okay. Now, Jackson, you're going to get a recording of this. So if you want to know exactly how to do this problem again for your homework or something, you can watch it on the recording. But that's the way to do it, is to set your variables up. Only use one variable. Don't use two. It just occurred to me that you haven't gotten to two variable equations yet. You're still in one variable equations. And so if you can set up a word problem as a one variable equation, then you only need one equation to solve it. Okay? I know I've taken you over by a few minutes. I apologize. I hope I've been helpful, and I will talk to you the next time, Jackson.
Thank you.
You're welcome. Bye-bye.
Yeah, how do I read this?